All right, 79 says the slider shown in figure starts from the top of a frictionless hill and slides down into the valley. What initial speed does the slider need just to make it over the next hill? Okay, so we can look at our equations here. Our potential energy, 1 for the top of the hill, can be given with this equation. Second, potential energy when they reach the top of the next hill can be given by this one. And then we can use the equation for kinetic energy. And we know that potential energy at the initial placement plus the kinetic energy that's going down the hill equal the potential energy where it comes to rest. If we have the slider doing something like this, ending on the same height. So we can substitute the potential energy 1 for mass times gravity times height plus 1/2 of the mass times the velocity squared, and that will give us the kinetic energy for the second resting place. So that's going to be, if we plug that in, VI. So we're trying to get velocity again isolated, so we divide everything by V, or everything from V, and that's what we'd end up with. And then from that we can just do the calculations, which is 2gh2 minus h1. And then V1 equals, the velocity is going to equal the square root of 2g minus the 2 heights. And so we can substitute those values in, which is going to be velocity equals square root of 2, 9.8 meters per second squared times 5.8 minus 4.5. Run out of room here. But that's going to equal 5.04 meters per second. That's the initial speed of the slider.